Hi guys, this is lesson 1 in unit 9. We're going to talk about our growth and decay functions. Growth and decay functions are exponential functions. The form for the exponential functions is f of x equals a times b to the x, where a and b are the parameters of exponentials. In linear functions, we have the form of y equals mx plus b. And we said that m and b are the parameters of linear functions. Same thing in exponential functions. A and b are the parameters of exponential functions. Now a is the initial value, so a is always the initial value, and b, which is usually in parentheses, is the exponential factor. Exponentials can be either growth or decay functions. When b, which is the exponential factor, is greater than 1, then we have a growth function, and b is called the growth factor. When b is between 0 and 1, that means we have a decay function, and b is called the decay factor. This is what a growth function and a decay function look like. The first graph here is an exponential growth, and this is what the exponential growth look like. And this is an example of an exponential decay. Let's take a look at these questions. Identify the parameters of the exponential function and identify if it's a growth or a decay function. We have g of x equals 3 times 0.7 to the x. So this is an exponential function because x is the exponent in this function. 3 is the initial value, and 0.7 is the exponential factor. Now, since 0.7 is a value between 0 and 1, that means we have a decay function. So 3 is the initial value, and 0.7 is the decay factor. Now, let's take a look at the other example, decay factor. In the other example, we have h equals 0.5 times 6 to the x. Again, this is an exponential function because x is the exponent. 0.5 is the initial value, and 6, which is the number in the parentheses and raised to the x, is supposed to be the exponential factor. Now, since 6 is greater than 1, that means that we have a growth, and 6 is called the growth rate or growth factor. It's the growth factor. Now, sometimes growth and decay factors can be represented as rates. When we have an exponential growth rate, then the growth factor is represented by 1 plus r. And when we have an exponential decay rate, the decay factor can be represented by 1 minus r. Let's look at this example. The value of Jim's investment is increasing by 4% each year. If his initial investment is $1,000, determine the following. What is the initial value? The initial value in this example is $1,000. Now, what is the rate? Reading the problem, we have 4% increase, which means we have a growth exponential function. And the rate in this case is going to be 0.04 because we're changing the percent into a value. And to change the percent into a value, all you need to do is to divide 4 divided by 100 because we have 4%. 4 divided by 100 is 0.04. What is the growth factor? The growth factor, as we said, when we have a rate, is 1 plus R, or 1 plus 0.04, which is going to be 1.04 equals 1.04. Write an equation which could be used to determine the total value of his investment after X years. That means I'm going to have f of X for years, equals the initial value, which is 1,000, times the growth factor, which is in this case 1.04 raised to the X. The total of his investment after 10 years, that means I'm going to have f of 10 because the number of years in this case is 10. So f of 10 equals 1,000 times 1.04 raised to the 10. And by placing all this in the calculator, you'll get the final answer.